Electric generators, all of them, in nuclear power plants, wind generators, portable generators, hydroelectric, coal-fired municipal generators, all are the same. They haven't changed in 100 years. The concept behind them is the same. They may have made improvements in the materials and stuff like that, but they still only will harness 85% or convert of the 100% that you put into a generator to spin it. Regardless of how you do it, you only get 85% out. And that's just the way generators have been for 100 years. This defies that, or in other words, improves that. That 15% loss is now gone. If you take a portable generator, gas engine, you start it up, it's running, and you plug it into a load and you start using that electricity, you hear the generator go, it slows down under load. And more than anything else, that's why you can only get 85% out of it. Because it has inefficiencies in the way the magnets are configured and the way the windings are taking out the electricity. And they actually fight themselves once the electricity is under load. So the biggest thing about this is that it doesn't slow down under load. That means every nuclear power plant can now get 15% more power. Hydroelectric, wind power, coal, or in the case of a coal power plant, you can put 15% less coal in and get the same amount of electricity, or that's 15% less carbon in the atmosphere. Now that's the lesser application of this technology, because there are many types of magnets. Here I've used electromagnets because I can turn it on and turn it off for the sake of my tests. The magnets that are in here could just be permanent magnet with no electrical requirement. So they wouldn't require any electricity, but there's power there to harness. And regular generators, like you see anywhere, even the big ones, have regular old permanent magnets. But there are more powerful magnets in this world. Some of them, commercially available, they're still made of iron, but they're way more powerful. They're about 10 times the strength of a regular permanent magnet. And if you take those stronger magnets and put them in a conventional generator, it will generate more electricity, but now it's going to fight itself that much more, because just in the inherent design. And so there's no way even more powerful magnets, even superconducting magnets, which are in the public domain, they're off-the-shelf item, which are the most powerful magnets. You can put those in regular generators and you'll generate more power in the windings, but it'll fight itself that much more and you'll get no more out of it. It's a well-known fact. So this method of extracting electricity, and in this case it's regular old AC like you have in the wall there, this method can extract more, much more. You can much more fully tap the potential in the naturally occurring phenomena of magnetism. And magnetism's been in the earth for millions of years, just sitting there. But in our current day methods, we cannot tap it fully. So this enables us to more efficiently tap it. Like I say, the lesser application of this technology is to improve the efficiency of every generator that we now use. That's huge.